All right, so I wanted to do a quick video just summarizing the graphing of absolute value functions, just to show you kind of the quickest way to graph this without necessarily needing to do a table of values every time. So when you have f of x equals the absolute value of x, we want to recognize what the a value is, and the a value is any number that's in front of that absolute value. So if nothing is there, then your a value is equal to a 1, because they're not going to write the 1 in. So what that means is your absolute value, you want to remember this is a v-shaped graph, so any absolute value function is v-shaped. The vertex is at the origin, and when your a value is 1, that tells you that you're going to go up 1 and to the right 1 and plot your next point. Then you're going to go up 1 to the right 1. It tells you how many to rise to get your pattern of points for your absolute value function. So if your a value is 1, you're always going up 1. And then that gives you the right side of your v. Now to get the left side, you're going to go up 1 but to the left 1. It's just going to be a reflection, a mirror image of the right side. And this is actually the parent function. This is what it will always look like if that a value is a 1. Now, domain we talked about in earlier videos. So domain is all real numbers. But the range, our output, all we got were a 0 and positive numbers for the output. So for the range, all of the y's are going to be greater than or equal to 0. Okay, so see how quick that was? That maybe took us a minute and a half. And that's because I was talking. All right, so this next one, we have g of x equals the negative absolute value of x. So our a value has changed. Now our a value is a negative 1. So all that means is we start at the origin like normal, and instead of going up 1, because it was positive, now we're going down 1. So we're going to go down 1 to the right 1, down 1 to the right 1. And then we're going to just get the mirror image of that on the other side, down 1 to the left 1. In our v shape, this is a reflection across the x-axis when your a value is negative. But that is what that looks like. We got it pretty quickly if we just know the shape of our graph and we understand how the a value helps us out. So domain of all absolute value functions is all real numbers. And then the range, the output, or the y values, they're all down here. So now we have all negative y's. We do have 0, because that point 0, 0 is our vertex. So all of our y values are less than or equal to 0. Okay, so let's just do a couple more to make sure if we see something a little bit different, we still understand how to deal with it. So our next one, our a value is a 3. So if your a value is a 3, you're still going to start at the origin. And now you're going to go up 3 and to the right 1. This is going to be a stretch of your graph. It's going to make your v more narrow. So I'm going to go up 3 to the right 1, and then I repeat that. I go up 3 to the right 1 again. You can see that this is a little bit of a steeper v. It's going to be a narrower v. Now to get the points on the left side, we're going to go up 3 to the left 1, up 3 to the left 1, and then we'll get those points. So with your absolute value functions, it's a V shape, and then you're always, to find the pattern of points, you're starting at the origin, and the rise, that's the thing that changes depending on your a value. The rise basically is your a value. Either it's going to be positive, so you'll go up, negative, you go down, but you will always go to the right one. All right, our domain is all real numbers. The fact that our a value is a 3 did not change that. And our range, the y value is the output, all positive here, including the 0. So all the y's are greater than or equal to 0. Okay, so last one here, our a value is a negative 1/2. Okay, so what that means is we're going to start at the origin. We're going to go down 1/2 and then over 1. Because whatever your a value is, that's your rise. So I'm going to go down 1/2 and over 1. And you can see how I'm plotting that kind of at a halfway mark. So now I'm going from there down 1/2 and over 1. Down 1/2, over 1, down 1/2, over 1. It's a little bit harder to do when it's not exact spots. So the fact that our a value is negative, it reflected our v across the x-axis, so our v is now opening down, and it's also widening the v, so this would be a compression. So now I'm going to go down a half to the left one. But see how we're always going to the right one or to the left one? It's just your rise changes depending on your a value. Domain continues to be all real numbers. And what that means again is you can have any input for x. You can take the absolute value of any number. So that's why your domain will be all the numbers. The range, however, when you take the absolute value of those inputs, the outputs in this example are all going to be negative because we're multiplying by that -1/2. It does include the 0, so all your y's are less than or equal to 0.